Welcome to the TVE Happy Math Hour, our weekly interactive math reviews for Math 1332 and Math 1320 and Math 2412. Presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. This session will be recorded so that you may come back to it later, and it is also recorded so that others who may have missed out on today's events will be able to come back and watch it. So for now, at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. And without further ado, I'll pass it on to our presenter so that we may begin.
Hello, everyone. Welcome to Friday Happy Math Hour. I think we're separating rooms today, maybe. Okay. Can you guys hear me? All right, sounds good. Okay, so for this, let me just close my door really quick. All right, so we'll get started. So I'm going to talk about Math 1332, but first I'm going to go over Webassign. And Webassign is basically the homework tool that you'll be using for your class. And so if we go ahead and start here, there's really two ways that you might enter Webassign. One way is using the class key that your instructor will provide to you. But there's some instructors who don't use a class key and they use a connection with Blackboard. So these are the two ways. The class key looks like this. And if your instructor doesn't give you a class key, then they probably have their classes linked with Blackboard and your class key will not be needed. Okay, so it depends on your instructor. And so I'll walk you through the process here really quick. When you enter your class key or you click on the Webassign link in Blackboard, it's going to ask you to register. So you would register using either, if you already have an account, you can log in with that same account, or you can create a new one. On the left side menu, you'll see your courses. If you click on that, you'll see your course listed there. And so you would enter the course. And this class has first day access, so you won't need to purchase any other materials. It's already included with your tuition. Okay, so this is not the right book for 1332. You would see the book that is for your class here. Once you're in there, if you want to change your password, you can by clicking next to your name. And again, the courses will list any products that you're using with Cengage. And then if you prefer to have like a physical book, you can rent the option here. There's a renting option. However, your access code includes an ebook. Once you are in your course, you can click on this. It looks like a little world. You can click on it. And you could even change your text, so you can choose English or you can choose Spanish if you prefer. And so if you selected Spanish, then it would just change all the tabs to Spanish. Here, it will let you know if you have messages, but if you click on it, it can also give you the opportunity to get notifications. So for example, if you want to get notified if your instructor changed the due date, then you can select this. Or if there's an announcement posted, or maybe your instructor sent a message. So if you click these, it'll notify you through email that something is happening in the course. You can also set reminders. So if you want a reminder for your due dates, then you can also select those here. Your ebook can be found on the right-hand side of the screen. And if you click on it, it'll let you see the ebook. And then some other important things, the My Assignments will list all your assignments. And then your grades, and then your communication. Okay. So once you have your assignments here, you might see some of these icons. And so if you see a little computer with a lock, that just means that it's a lockdown browser. And if you see this one here, it means that it's password protected. This one means that there's a time limit. And we'll keep going here. Now, once you're in your assignments, there's some tools within it. So you might see these orange buttons in some of the questions. And so some will have a read it, which just opens the ebook. Some will have a watch it, which if you click on it, it'll give you a video similar to that example. And then not all the questions have it, but some will have it for you. And so that was just a glimpse of Webassign, which is again the tool that you'll use for your class to do homework. So in 1332, we're going to look at a couple of sections. So today we might have time to cover examples from 3 sections. The first section, 1.1, is going to talk about inductive and deductive reasoning. And so inductive reasoning is the process of reaching a general conclusion by examining specific examples. And deductive reasoning is a process of reaching a conclusion by applying general assumptions or procedures or principles. So they put the link to Math 1342, to Math 2412 in the chat. So if you're here for Math 2412, then you want to click the link to send you to the other room. Okay, so for inductive reasoning, what's happening is you're going from something specific to making a general statement. And in deductive reasoning, you're going from general to specific. So we'll do a couple of examples. It says determine whether the following argument is inductive or deductive. So the first one says the last mayor was honest. The current mayor is honest. Therefore, all mayors are honest. So if you like, in the chat, you can take a guess if you think that this statement is inductive or deductive. So just to refresh, we're going from specific to general is inductive. General to specific is deductive. So the first one, the last mayor was honest. The current mayor is honest. All mayors are honest. So what do you think that is, inductive or deductive? Okay, so here we see that the first one, we have 2 specific examples, the last mayor, the current mayor, and now we're making a general assumption. And so this first statement is going to be inductive. The second one, every word has the letter E in it. Therefore, your name has the letter E in it. So this one's making a general statement, and then it's going to one specific example. So we would say that's deductive. At any times, if you have a question, please let me know. So the next one says use inductive reasoning to predict the next number in each of the following lists. Okay, so we have the first one, 3, 6, 9, 12, and 15. So we want to observe what's happening from each number to the next. Okay, so if we look at the first one, we go from 3 to 6. Then the second one goes from 6 to 9. Then we go from 9 to 12 and 12 to 15. So if we look at it a little bit carefully, we're seeing that we added 3 plus 3 gave me 6. 6 plus 3 gave me 9. 9 plus 3 gave me 12. 12 plus 3 gave me 15. So by inductive reasoning, I can assume that the next term would be 15 plus 3, which is going to be 18. Okay, let's try example B. We have 1, 3, 6, 10, and 15. Okay, so I'll give you a second to try to work it out on your paper or in front of you, and then we'll go over it. So we have 1, 3, 6, 10, and 15. So you want to look for a pattern, right, to see what's happening. So in the A, we were just adding by 3 all the way across. But here, if we were trying to add a number, we would have 1 plus 2 is 3, but 3 plus 2 is not 6, right? So 1 plus 2 is 3, 3 plus 6 is 3, 6 plus 4 is 10, 10 plus 5 is 15. So maybe the next one might be, so if you notice from 1 to 3, it differs by 2. From 3 to 6, it was by 3. 6 to 10 was by 4. 10 to 5 was by 5. So maybe the next one would be 6. So 15 plus 6 would be 21. Okay, so you want to try to look for those patterns. So let's try this example. So it says complete the following procedure for several different numbers. So it says pick a number, multiply the number by 8, add 6 to the product, and divide the sum by 2, and then subtract 3. So I'm going to pick a number. So I chose 5, and it says to multiply by 8. So 8 times 5 is 40. And then it says to add 6. So 40 plus 6 is 46. And then it says to divide the sum by 2. So 46 divided by 2 is 23. And then subtract by 3. So 23 minus 3 is 20. Let's do this again with a different number. Let's try 10. So 8 times 10 is 80. Then we're going to add 6. 80 plus 6 is 86. Then we're going to divide by 2. 86 divided by 2 is 43. And then we're going to subtract by 3. 43 minus 3 is 40. Okay, so let's try one more. So 7, we have 8 times 7 is 56. 56 plus 6 is 62. And 62 divided by 2 is 31. 31 minus 3 is 28. Okay, so if we look at the original number and the final number, so in this case 5 and 20, this one was 10 and 40, 7 and 28. You want to ask yourself what is happening with this procedure. So if you pick any number, let's say you pick 6, what would your final number be? Okay, so you want to look at the pattern. So what's happening with 5? We ended up with 20. 10, we ended up with 40. 7, we ended up with 28. So the big question now is, let me write it here. What if we had a 6? Okay, so if we had a 6, what would we end up with? So let me go ahead and, so in a little bit we'll answer that one if that's not already answered in the next slide. But let's see what I have on this next slide. Okay, so what do you notice about the original number and the final number? And so hopefully you can see that the final number is 4 times the original number. So if you have 5, 5 times 4 is 20. 10 times 4 is 40. 7 times 4 is 28. So if we had 6, which is the one I asked earlier, then we would have 6 times 4, which is 24. So the final number is 4 times the original number. Is this an example of inductive or deductive reasoning? And so this would be inductive because we're going from specific to general. So I could say if you follow this procedure with any number, then it's always going to be 4 times your original number. So if your original number is 12, what would be your final number? So your final number would be 12 times 4. So we would end up with 48. So if you follow all the steps, multiply, add, divide, subtract, then you would end up with 48. Okay, so let's consider the same problem. But now, what if your number was n? let's say we didn't know what n was, then let's see what happens. So if our number was n and we multiply by 8, we get 8 times n, which is 8n. If we add 6, we get 8n plus 6. And if we divide by 2, we get 8 divided by 2 is 4n, and 6 divided by 2 is 3. Subtract 3, and we end up with 4n. So we started with n, and we ended with 4n. So this procedure here gives us 4 times the original number, the same as before. But since we're going from general, because n can be any number, then we say that we're using deductive reasoning here. Okay. So now we're going to look at solving a logic puzzle, So we have Brianna, Ryan, Tyler, and Ashley were recently elected as new class officers, president, vice president, secretary, and treasurer of the sophomore class at this college. From these clues, you want to determine what each person's position was. Okay, so one of the strategies you can use here is to make a table. So we have a president, a vice president, a secretary, and a treasurer. And then they give us, there's 4 people. So Brian, Ryan, Tyler, and Ashley. So then we start with number 1. Ashley is younger than the president, but older than the treasurer. So from that sentence, we want to make, eliminate what Ashley is not. Okay, so Ashley is younger than the president. That means that Ashley is not the president, but older than the treasurer. So Ashley cannot be the treasurer. Okay, treasurer. Okay, so what I can do is I can mark these, cross them out, because Ashley cannot be either one of these. Okay, so we go to number 2. Brianna and the secretary are both the same age, and they are the youngest members of the group. So what can we eliminate with that statement? Okay, so Brianna and the secretary. So that means that Brianna cannot be the secretary. Okay, and then we'll come back and we'll reread them if we need to. Let's go to number 3. Tyler and the secretary are next door neighbors. So that tells me that Tyler cannot be the secretary. And so he's right here. So we scratch that out. Okay. So if we look at our table, we still don't have enough information to determine what each person is. So when that happens, you want to go back to read the statements and see if you can figure out what else we can use in those 3 things that they give us. Okay, so Ashley is younger than the president, but older than the treasurer. And then Brianna and the secretary are both the same age, and they're the youngest members. Okay, so what we can do here is it tells us that Brianna and the secretary are the youngest members. So that's a keyword here, the youngest members. Ashley, in sentence number 1, is older than the treasurer, therefore can be the secretary, because Brianna and the secretary are both the youngest. So if Ashley is older than the treasurer, then she can't be the secretary. So we can cross out, let me go back here really quick. So Ashley, we can cross out that she's not the secretary. Okay, so now I have this one open space for secretary, so that means that Ryan is our secretary right here. All right, and then if we look at our table, then we can see that, let me go back again, there's an empty space here, everything else is taken. So that means that the vice president has to be Ashley. Okay, so now we're left with Brianna and Tyler. So if we continue, it says Brianna is the youngest, but Ashley is younger than the president. Therefore, since Ashley is younger than the president, therefore Brianna can be the president because Brianna is the youngest. But if Ashley is younger than the president, that doesn't make Brianna the youngest. So therefore, Tyler would be the president and Brianna's the treasurer. Okay, so you want to mark your clues, but if only 3 clues are given, then you want to see if there's any other hidden things that we can use. In this case, it was the age that was letting us know what was going to be next. Okay, so these are actually fun. You can do these with your family, right? And have a lot of fun there. So those were just a couple of things from section 1.1. Section 1.2, problem solving with patterns. So we're going to look at these sequences a little bit in more detail. So it says an ordered list of numbers like this one, 5, 14, 27, and so on, is called the sequence. And the sequence are separated by commas, and each of these numbers, we call them terms. And then if you notice here, it has 3 dots. The 3 dots means that it's going to go on forever, and we call it an ellipsis. And so again, that's where the third statement here, it's going to go beyond 65. And then in the above sequence, 5 is the first term, 14 is the second term, and so on. And then since we don't know where the sequence is going to stop, we can call it the nth term to represent, we could stop at the 80th term or the 90th term, or it could keep going. So in the first few slides, we were looking at sequences and trying to figure out what came next. So in this sequence, what is going to be the next number? So if we look at each of these numbers and try to find a pattern, so we have a 2, then we ended up with a 5. So if I added 3, I would get 5. If I add 3 to 5, I get 8. And if I add 3 to 8, I get 11. 11 plus 3 gives me 14. So 14 plus 3 is 17. It should be my next number, right? So what we want to focus on in this section is a difference table. We can use a difference table to help us figure out what the next term should be. So if we have 2 and 5, the difference between 2 and 5, so 5 minus 2 is 3. 8 minus 5 is 3, 11 minus 8 is 3, and 14 minus 11 is 3. This first row is called the first difference. And if it has all the same numbers, then we can stop to figure out what the next number should be. But sometimes it's not going to be the same, and we'll talk about that in a little bit. Okay, so what we can do here is, now that we know that this is 3 and this is 3, then I can assume that the next one will be 3. And so let me just draw something here. So I can use inductive reasoning and say this would be 3. So 14 plus 3 would be our 17. Okay. So let's go to another one. So now we have 5, 14, 27, 44, and 65. So if we look at this number, it might be hard to find like what's happening between each term. So a difference table would help us to figure out the next term. So if we construct the difference table, 14 minus 5 is 9, 27 minus 14 is 13, 44 minus 27 is 17, 65 minus 44 is 21. But notice that these numbers here are not the same, okay? So it's really hard to make a prediction when these are not the same. So we go ahead and do another difference, and we call that the second difference. Okay, so let me press next. And so we do the same thing. 13 minus 9 is 4. 17 minus 13 is 4. 21 minus 17 is 4. And so now I can see that these are the same. So I can go ahead and use inductive reasoning to figure out the rest. So here, 21, the next one would be 4. So 21 plus 4 is 25. and then 65 plus 25 would give me 90. So 90 would be my next term. Any questions? Okay, we'll try one more. I'll give you a second or so to try to see if you can figure this out, and then we'll go ahead and continue. So here it says use a difference table to predict the next term, and your sequence is 2, 7, 24, 59, 118, and 207. So to start the first difference, we would say 7 minus 2, 24 minus 7, and so on. So you should have something like this. So 7 minus 2 is 5, 24 minus 7 is 17, 59 minus 24 is 35, and 118 minus 59, 59, and 207 minus 118, 89. The numbers are not the same, so then we consider doing a second difference. And so let's do that. So 17 minus 5 is 12, 35 minus 17 is 18, 59 minus 35 is 24, 89 minus 59 is 30, and then this number here is, I'm just copying it down from here. Okay. So again, we see here that these are not the same, so maybe a third difference would help us. So if we go with a third difference, 18 minus 12 is 6, 24 minus 18 is 6, 30 minus 24 is 6, and so now they're the same, so we can work back up to figure out the answer. So 30 plus 6 is 36, plus 89 is 125, and 125 plus 207 will give us our answer, 332. Okay, so using these differences will help us. So here's just a picture of everything together without my scribbles here. And so that would be your answer, 332. Okay, so now we're gonna jump into section 1.3, problem solving strategies. And so there was a mathematician by the name of George Polya, and he came up with some advice or basic problem solving strategies. And so he said, if you're trying to solve a problem, then you should really understand the problem first, try to understand it, devise a plan, carry it out, and then review your solution. And so within this Polya's 4-step problem solving strategy, strategies that you can use, for example, would be making a list. Guess and check is also a strategy that you could use, but guess and check without guessing, without the checking, is not a good strategy. But if you guess and check, then that is considered a strategy. So guess and check, making a list, drawing a picture, and maybe I should say making an organized list, because you want to keep track of what you're doing. Okay, so we'll work out a few examples here. So the first one, the number of ducks and pigs in a field totals 35. The total number of legs among them is 98, assuming each duck has exactly 2 legs and each pig has 4 legs. Determine how many ducks and how many pigs are in the field. So there's different ways of solving this problem. So I'm going to go over 2 ways. The first way, well, first we need to understand the problem, which is basically how many ducks and how many pigs do we have in this field when we have 35 animals altogether. So then we need to devise a plan. So my plan is going to be to draw a picture. And so I'm going to carry it out on the next slide. So these are my animals, right? There's 35 animals, so I drew 35 circles. Now, what does the legs, what does the pig and the dog, how many legs do they have in common? Well, they each have at least two legs, right? So I'm going to draw 2 legs on all my animals here. So if I draw 2 legs on each of these, then I have 70 legs, okay? So I'm still missing some legs here. So I'm going to keep drawing legs until I get to 98. So that's what I did on my next slide. So I added some more legs here until I reach 98 legs. So once I did that, now I have 98 legs drawn up here. So I know that the pigs have 4 legs. So how many pigs do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pigs. And so that leaves me with 21 ducks. So if I count these 3 rows, it's 21 ducks. So that is one strategy that you can use, is draw a picture, okay? So drawing pictures can help us see what the problem is asking for, and maybe even finding the solution. Now another way that you could do this is, let me go here, is to use algebra. So depending on your algebra skills, right? Let's go ahead and read this. So it says the number of ducks and pigs is 35, but we don't know how many ducks and we don't know how many pigs. So I can set up an equation. I'm going to call my ducks, I'm going to call them D, and my pigs, I'm going to call them P. Together, D plus P, so my dogs, no, not dogs, my ducks plus my pigs would be 35. So that's one equation that I can write. Then they tell me that the total number of legs is 98, and the ducks have 2 legs, and the pigs have 4. So I have that my ducks have 2 legs, and my pigs have 4 legs, and all together I should have 98 legs, okay? So this is a system of equations, and so we're going to go ahead and solve for the variables. And so in order to solve for this, there's different ways you can approach it. I'm going to use the elimination method, which means that multiplying this first equation by a -2. So -2 times D is -2D, and -2 times P is -2P, and -2 times 35 is -70. Okay, why did I want to multiply by -2? Is the reason is because I want to cancel my variable D. So if I add these 2 equations together, -2D plus 2D is going to be 0, and -2P plus 4P gives me a 2P, and -70 plus 98 gives me a 28. If I divide by 2 on both sides, then I get P is equal to 14. Now that you know your P is 14, you know that you have 35 animals, so you can subtract them. Or in algebra, we say we back substitute, right? So you can back substitute in here. But subtracting will probably just be faster if you're trying to get to your answer. But back substitute is, what that looks like is you pick any of the 2 equations. I'm going to pick the first one, D plus P is equal to 35. We already know what P is. P is 14, so I write 14 for P, and then we're trying to solve for D. So if we subtract 14, then we get D is equal to 21. Okay, so once you solve for your variables, don't forget you want to go back and finish with a sentence, right? We have 14 pigs and 21 ducks in this field. So this is an example of a problem that you can use, draw a picture, or you can use algebra to solve the problem. Okay, let's try another one. So John needs to figure out what the last digit in the ones place of the number 4 to the 200th power is. He is willing to give the first person who can tell him his number a price. What is the last digit of the number 4 to the 200th power? So our first reaction might be to, well, what would your first reaction be to finding this answer? I could almost assume that most of us, we would probably go and grab our calculator and figure out what 4 to the 200th power is, right? So if you have a scientific calculator, that's not gonna work. It's not gonna give you the answer. This number is too big. So maybe if I have a graphing calculator like a TI-84, that should do the trick. So no, you're not gonna get an answer from that calculator either. So one of the strategies to solve this problem is to look at a smaller case. Okay, so let me highlight the word smaller. So this number here is way too big that our devices will not give us an answer. Okay, so we consider a smaller case. So what if we had 4 to the first power? Then that answer is going to be 4. If we have 4 to the second power, we get 16. If we have 4 cubed, we get 64. 4 to the fourth, we get 216. 4 to the fifth, we get 1024. If you're not able to see a pattern yet, then you can keep going a little bit further, see if you see a pattern. But what is happening here, it looks like I'm alternating between 4 and 6 for my last digit in the ones place, right? So for 4 to the 6, then I can assume that this would be ending in a 6, right? Because we have 4, 6, 4, 6, 4, 6. So what you can do is list all the way to 200 and get your number, but that would take some time, right? So we don't want to do that. Instead, we can see, okay, how do I know when it's a 4? How do I know when it's a 6? So if we observe the exponents here, when it's a 1, a 3, and a 5, we ended up with 4. So these numbers, 1, 3, and 5, these are odd numbers, right? These are odd numbers. So anytime that it's an odd number, it looks like it's ending in a 4. And if we have a 2, a 4, and a 6, it ended in a 6. So if it's an even number, it's ending in a 6. So that tells me that if you have an odd number, it ends in a 4. If you have an even number exponent, it ends in a 6. So we have 4 to the 200. So we need to figure out, is 200 even or is 200 odd? So 200 is even. Therefore, this number should end in a 6, okay? Since it is even. So the number will have a 6 in the ones place. That's what it means by ones place. Is basically what is that last number, okay? And so again, the strategy here is if something looks very complicated, try to look at a smaller case. All right, so let's go to another problem. So here we have a cartoon. It's a little bit hard to see, so I'm gonna read it, but let's help her solve this problem. So it says, in driving from town A to town D, you've passed first through town B and then through town C. So she's okay. She's okay. It is 10 miles farther from A to B than from B to C, and 10 miles farther from B to C than from C to D. If it is 390 miles from A to D, how far is it from A to B? So she's thinking about it, and well, I knew it would happen sooner or later. What's the matter? My education has ground to a halt. but we're gonna help her so that she feels better. Okay, so let's break this problem down. So I'm gonna draw a picture as my strategy. So I have town A, B, C, and D. I don't know what's going on between the towns, but I know that the order A goes through town B, C, and D. So this is the order of, if you're traveling from A to D, you're gonna go through B first, and then from B to C and C to D. So I drew my little towns here. So now I also know that from A to D, they tell me that it's 390 miles from A to D. So I'm just gonna write 390 here so I can remember that. And now I'm gonna focus in this second box because everything else is gonna be in here. It is 10 miles farther from A to B than from B to C. So I need to identify something here, right? So let's say we don't know what the distance is from B to C. Let's say we didn't know what that was, then we can call it X. And then from A to B, it's 10 miles farther from A to B. So in here, this should be 10 miles more than what it is in here. So I can represent that as X plus 10. And then from C to D, it says, where is it? And 10 miles farther from B to C than from C to D. So if B to C, I already called that X, then C to D is 10 miles less than this area. So now I have X minus 10. But all together should give me 390. So I can add these together, X plus 10 plus X minus 10 equals 390. So we get X plus X plus X is 3X. 10 minus 10 is 0. So we're left with 3X equals 390. Divide by 3. So X is 130. So you want to go back because they want to know how far is it from A to B. So we want to know what this is. Okay, so sometimes when we're doing problems like this and we solve for X, we think that we're done, right? But you always want to make sure the last step in the poly solving strategies, problem solving, is that you need to check your answer right, because here it's asking us A to B. So we plug that in, we get 130 plus 10 is 140. And if we figure out C to D, that would be 120. If you check your work, then all of this is equal to this number. Okay, so that helped in drawing a picture and going from there. So another problem here, I like this problem because I like this movie, Die Hard. This is just a screenshot of the video. I'm not gonna play it, but if for some of you, maybe you have never watched this movie, but if you watch it, there's a scene in the movie where they have to figure out this math problem. I actually used different numbers than the one in the movie. I think the one in the movie was 3 and 5. But if they can't figure out, if they can't answer the problem, then there's a bomb that's gonna explode. Okay, so we're gonna go ahead and do a similar problem. I have a 3-gallon bucket and a 7-gallon bucket. I have a source of water and can empty water into a pond. I do not have other containers, so you only have these 2 buckets. But you need to measure exactly 2 gallons of water. Okay, so in this movie, it was important, or else they were all gonna die. But thankfully, nothing's gonna happen to us. If we mess up, we just try again. So here I'm gonna use a table. So I have the action, the amount of 3-gallon bucket, and then the 7-gallon bucket. So a solution here is I'm gonna fill my 3-gallon bucket with water. So that means that this one has 3 and this one has 0. Then I'm gonna empty my 3 gallons here. I'm gonna pour it into the 7 bucket. So now I have 0 here and I have 3 here. Then I'm gonna get some more water into my 3-gallon bucket. So I have 3 gallons of water in my 3-gallon bucket and 3 gallons of water in my 7-gallon bucket. So I'm gonna pour my 3 gallons into the 7 bucket. So now I have 0 and now this one has 6. Okay, so I go ahead and get 3 more gallons, and I'm going to pour it into my bucket with 6 gallons. Well, since this bucket only holds 7 gallons, if I pour 3 into the 6, it only is going to fit 1. So now this would have 7, this one would have 2. And so that is the procedure of how I would get exactly 2 gallons of water. Okay, and that was it for that answer. Okay, this one, I have 5 coins in my pocket. The coins are either nickels or dimes, or a combination of nickels and dimes. List all the values of money that we could have. Okay, so we start, guessing like, okay, what if I had this many nickels and this many dimes? We would get our answer, but the strategy here is to make an organized list. That way you can, the strategy here is to make an organized list. That way you can keep track of what you already did. So here, for example, what if I had 5 nickels? Then the value of my nickels is 25 cents. But if I have 5 nickels, that means that I have to have 0 dimes. And the value of that would be 0. So my total value would be 25. Or what if I had 4 nickels? That means that I have 1 dime. So the value of my nickels would be 20. The value of my dimes would be 10. And the total amount I would have would be 30. Or what if I had 3? So 3 nickels would give me 15 cents. If I have 3 nickels, I have to have 2 dimes. So then I would end up with 20. So I get 35. Then we have 2. So 2 nickels gives me 10. But if I have 2 nickels, that means that I have 3 dimes. So the value of that is 30. 30 plus 10 would be 40. And I could have 1 nickel, 4 dimes. So the value would be 50. And then the last option would be 0 nickels, 5 dimes. So we would have 50 cents. So it says list all the values of the money that we could have. So we could have 25 cents, 30 cents, 40 cents, 45, or 50 cents. So the idea here is that if I'm organized, then I would, it's going to cause less frustration because I can see that I've already used these options here. All right, so here's another different strategy. I left home with some money. I spent half of my money for hot chocolate. I then put $1 in the Salvation Army kettle. At that point, I had $4. How much money did I start with? So the strategy here is to work backwards. So working backwards can help us get to our solution as well for some problems. So I made a little table here, amount that I had, the action just before I had that amount, and the amount of money I had before the action. So here, since I ended up with $4, I had $4. So we work backwards. What did I do before I had $4? I put $1 in the Salvation Army kettle. So I'm going to say I donated $1. So then if I'm working backwards, and I'm going to have 1 plus 4, which is equal to 5. Okay. So now I have $5. So what did I do before that? So here in the problem, it says that before I put this dollar in the Salvation Army, I first I spent half of my money for hot chocolate. Okay, so I had $5. I spent half on hot chocolate. So that means I should have had 10 to begin with. Okay, so we started with $10. So working backwards can help us find our solution as well. Here's another one. A frog is at the bottom of a 17-foot well. Each time the frog leaps, it moves up 3 feet. If the frog has not reached the top of the well, then the frog slides back 1 foot before it's ready to make another leap. How many leaps will the frog need to escape? So I already drew this on the other slide, but let me just kind of draw something here so you can see on the other slide why I did that. So let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. So here is my well, 17-foot well. And so you have your frog down here. So the poor thing is over here. And it's trying to get out of the well. So in the problem, it says that it leaps. When it jumps, it goes up 3 feet. And if it hasn't reached the top, then it falls back 1 foot before it can jump again. So if we jump, we go 1, 2, 3. We are not at the top, right? So our froggy is going to fall back to the one below. So then it jumps again, 1, 2, 3. We're not at the top yet. So then the frog has to come back down. And then we jump again, 1, 2, 3. And the frog is still not at the top, so it falls down 1. And then we go again, 1, 2, 3. And then the frog is not quite there, so it comes back down. 1, 2, 3. It's still not there, so it's going to come back down. So then we go 1, 2, 3. And it's still not there, poor thing. And then 1, 2, 3. It's almost there, but it's not quite there. And so we go back down, and then 1, 2, and it's finally out. So now it's happy, and it's gonna go do whatever it planned to do. So to get our answer, how many times that it need to jump? So we have the green, the pink, the blue, the black, the yellow, gray, orange, and black. So we have 1, 2, 3, 4, 5, 6, 7, 8 times. So it had to leap 8 times before it could get out of the well. So the strategy I did here was to draw a picture. And the next slide, it just shows you, it just shows what I did, the same thing. So 8 leaps. Okay, so for this week, maybe some of you have covered some of these type of problems, 1.1 through 1.3. If your instructor didn't get there, then they might get there sometime next week. But next week, we're going to start with chapter 2, which is on sets. And so we'll be covering that material. So what we do here in Friday Happy Math Hour is we try to cover examples from sections on the calendar in your syllabus. So if you look at your syllabus for week 2, then you'll see that the next sections will be on sets, chapter 2. So if you have any questions, we have our tutors here to help you. And I think that'll be it for today. Invite your friends. Join us every Friday at 11. This presentation, you guys can download it. Somewhere on the right-hand side where my mouse is, you should see a box with an arrow pointing down. If you click on that, it'll let you download this presentation. And then we have this being recorded. And so throughout the chat, they put our YouTube links in there, so you can always go back and watch the video again. But thank you for joining us, and I hope to see you next week. So I'll pass it over back to.
Thank you so much, Ms. Ruka, for your wonderful presentation. So again, we do want to remind you all about the previously recorded sessions, that they're going to be available on the YouTube playlist. This session will also be available on that playlist later today. And before you all leave, I want to share the TVE sessions that we'll have next. So at 1 p.m. today, we'll have a presentation from the Student Success Tutoring team, and we will be back next week at 11 a.m., where Math 1332 will cover set theory, basic properties of sets, complements, subsets, and Venn diagrams. And Math 2412 will cover trigonometric graphs. Hard word. Our 1 p.m. session next week will be a presentation on the Open Computer Lab and ISC. Thank you all for coming in today. We hope you all have a lovely weekend. And if you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.